Alright, oops. Lab 3 Black Holes and Orbits. The intro. The purpose of the lab is to find the mass of a black hole and to create a code that mimics the trajectory of a spaceship flying off a moon towards a planet. To do so, I must set up multiple functions and solve them step by step. What's what? In the first part of the experiment, we are given a star of mass 2 to e to 30th kilograms as orbiting a black hole of an unknown mass, and the system is a star. In the second part, the systems are either the spaceship or the moon, depending on which one you want to focus on, and the surroundings of the planet are the planet and whatever option you didn't pick for the system. So, for the surroundings of the moon would be the spaceship and planet. So the surroundings of the planet, no, surrounding of the moon, surrounding of the spaceship would be the moon and planet. What formulas will we use? In part 1, we need to find the mass of the black hole, so I use the gravitation formula, as seen at the bottom of the screen, and reverse engineer it to get back the mass of the black hole. At the end, because of the force not being constant, I took the mean of the points to get a final answer. In part 2, I used position update formula and the velocity update formula. I also used the gravitation formula to find the force. For part 1, I use a C specific specify a C specific to my email to get position data. Then, given the velocity of the starter code, I divided the velocity by mass to get momentum, and then use momentum to get Fnet. Next, I calculated delta V and delta P, then calculate the change of the magnitudes over time, change in time, and then Fnet parallel. I then used those to subtract them from Fnet and delta P over delta T to get delta P perpendicular, or delta P over delta T perpendicular, and Fnet perpendicular through subtraction. Now I use the gravitation formula to get the mass of the black hole, same way I did, or no, I just reverse engineered to get the mass of the black hole. For part 2, depending on what the system was, I found the position and the force relative to the surroundings, then used the respective forces to update the position and velocity. And then after that, I experimented with the initial velocity of the spaceship to figure out what velocity I would need to have to show that both the planet and the moon were active forces of gravity. And these are the codes I used. For discussion, for part 1, the parallel and perpendicular components represents the aspects that different aspects in the rate of change of momentum. Parallel to the parallel components tells you how much an object is speeding up, and the perpendicular tells you how sharp the object's turning. For part 2, the black hole add to the system, then everything else will most likely gravitate towards it. I will have to account for the gravitational force of the black hole, which would most likely have an overwhelming amount of mass, which means it would negate the other forces.